In Lesson 2 of Chapter 0, we're going to look at two objectives, but really related to the same idea, and that is using the distributive property to expand polynomials. So we've got some vocabulary words here. It's called the distributive property, which we should be familiar with. The word polynomials, poly means many, and nomials are products of monomials, so we can look at some of that. We also want to use the FOIL acronym to assist us in applying the distributive property when multiplying the two binomials. So I would guess that you're pretty familiar with the distributive property and the FOIL acronym. We're going to go back and we're going to review some of this. So what does distributive property mean or indicate? Just in a different example, there's something I can apply here. If I have 2 times 3 plus 4, and I ask you to evaluate this, and evaluate means try to get it back to one number, so we're going to evaluate this expression. You've been taught to use an acronym, PEMDAS, to find the value of this. Now, evaluate means we have to come to a final solution to this expression. So our order of operations asks us and tells us to do the parentheses first. So we're supposed to do the things or the operations inside the parentheses first. So we have to wait with this 2. And the 2 sitting outside the parentheses, that's a little bit of a push for some folks as well, because there's nothing in between here. And every time you see or you don't see something by a number in a parentheses, it implies multiplication. So it's called implied or implicit multiplication. There is a multiplication sign here, even though you don't see it. Sometimes you have to put a dot, and depending on your TI calculator that you use, sometimes your TI language doesn't recognize implied multiplication. You actually have to put the multiplication sign in there, otherwise it'll give you a syntax error. So those of you that have encountered that problem before, you kind of know what I'm talking about. So when I look at this problem here that we're going to do in a bit, there's a parenthesis and there's a 3x right next to it, but there's nothing else there. So when I see that, I automatically clue into this implied, implicit multiplication, that this 3x is supposed to be multiplied times the result of whatever you get out of that parenthesis. So let me come back to my first example here that we're working on. So it said we're going to take 2 times the result of whatever 3 plus 4 was, and 3 plus 4 is 7, and then then we finish up with our multiplication, so it's 2 times 7, or 14. Now the distributive property allows us, or affords us an opportunity to do this differently. It allows us to break down these rules of PEMDAS with this exception that we can multiply over the multiplication and then do the addition. So what I really have is an alternative path of finding the same answer, 14. So I'm going to erase this word and remember that our answer was 14. The distributive property allows us to temporarily bypass the parentheses first. We don't have to evaluate what's in those parentheses first. We have another option. The distributive property says that we can go ahead and multiply over the addition or subtraction that's in there and then come back and add. So here's what we're saying that we can do. We can take this 2 times 3, then we can add it to the result of 2 times 4. And this is the distributive property in action. The 2 times 3, now I'm going to come back and apply our order of operations. It is multiplying, so 2 times 3 is 6, plus our 2 times 4, which is 8, and 6 plus 8 is 14, we get the same result. Now, whenever we use the word property, means it is always true. It will always hold. There's never an exception to the rule. So the distributive property says we can always do this and get the same result. It doesn't really matter. Now, in the example I showed you, you might say, well, why would I do that? Why would I just do the order of operations and simplify that way? And you're right, you can. But sometimes you get algebraic expressions like we're going to use next. You don't have the ability to collect the like terms on the inside. So if we come to this example here and we try to use PEMDAS in this example, we cannot collect anything in here because there's no like terms. So our order of operations, where it says do what's inside the parentheses first, breaks down. There's nothing there that we can do. We can't simplify this or go any farther than this expression as it is right now. But if we apply the distributive property, it allows us to do at least one more thing that many times in algebra is a big advantage for us when we simplify larger and larger expressions. So I'm going to rewrite this expression, 3x times 2x squared minus 5x cubed. Just a couple of vocabulary words. This guy out here, it's called a monomial. Mono means one. Mono has one term, and these terms are combined or kept together with multiplication or division. So terms are basically pieced together with multiplication division. The other part in here, this part in here, is called, I can write them in here, a binomial. Binomial means there are two terms, and this one over here, I'll write the name on it. This was called a monomial. Monomial is a product of variables and numbers. So x is a variable, 3 is a constant. So monomial, as long as it's a product, a multiplication of numbers and variables, it's called a monomial. But if you have binomial, a binomial combines two monomials. So this part right here is a monomial, this part right here is a monomial, but when we combine them, put them together in those parentheses, we've got two monomials and it becomes the word binomial. So you're familiar with the word bi, so that's not such a big deal about putting that piece of the puzzle together. So what are we looking at doing here? What we're going to do is we're going to apply our distributive property, which is a pretty simple task here. What we're going to do is we come back through and we're going to distribute the multiplication over addition. So the process is pretty simple. Let's quickly get to it. We take the 3x times the 2x squared. So I'm going to take the 3x times the 2x squared, and then we're going to subtract. You can distribute over addition or subtraction. Then we're going to take the 3x times the 5x cubed. So 3x times 5x cubed. And now we can simplify again. We could take our 3x times our 2x squared. Well, 2 times 3 is 6. And an x times an x squared is an x cubed. Minus, then we've got 3 times a 5, and 3 times 5 is a 15. And an x times an x cubed is an x to the 4th. Now, these cannot be simplified any further because they are not like terms, but yet our final expression is a little bit simpler than our original one. So this is applying the distributive property. Again, distributive property means we can multiply first, then add and subtract. We just broke down our rules of order of operation temporarily. Okay, let's take a look at the second example here. In our second example, we got a negative 2x cubed, that's a monomial, times, and then 7x squared minus 8x minus 3. Now, because this is in a parenthesis, all three of these things are put together, so this is called a trinomial. Trinomial means we put together 1, 2, 3 monomials. Whether that's that big a deal or not, we'll see, but we've got, our task here is to apply our distributive property. None of these things inside the parentheses are like terms, so then all we can do to try to help us with simplifying this expression is apply the distributive property. I like to draw these arrows because it makes my mind think about I'm going to multiply over the addition and subtraction. So I'm going to take this negative 2x cubed and I'm going to multiply it by the 7x squared. Then I'm going to take the negative 2x cubed times the negative 8x. So I got a negative sign sitting right here, so I've got that. Then I'm going to take a negative 2x cubed times the 8x. Now there's lots of ways to interpret how you want to do that. This is the way I chose it. I chose to interpret this as a subtraction sign, so let's subtraction sign. Then I got the negative 2x cubed times the 8x. Then the next one I have is another subtraction sign. So I can also think of it as this. I got a negative 2x cubed, so I'm going to put the negative there. I got negative 2x cubed times our 3. I can only use that subtraction sign once. Then I'm going to perform the multiplication. Negative 2 times 7 is a negative 14. Then we got x cubed times x squared, which is x to the 5th. And negative times negative is a positive, and a 2 times an 8 is 16. And an x cubed times an x is x to the 4th. And a negative times negative, once again, is a positive. And then we got 2 times 3, so I better do the 2 times 3, which is 6x cubed. So I took a little bit of time trying to explain to you what the distributive property is, and then I performed the distributive property on a couple of examples. Just remember, you multiply first, then you can do your addition subtraction. And when we get down to the end, like I have in this green, there are no like terms here. X to the 5th, x to the 4th, x to the cubed. They're not like terms, so there's no more combining. We're simplified as far as we can go.